All right. Hello, ladies and gentlemen. Today we're going to take a look at what I call coupled systems. This is Physics 11, and you should be watching this because you're in Physics 11. If you're not in Physics 11, you don't need to watch this. We're going to go through some examples. Coupled systems mean you've got parts joined together. And generally they're going to be joined by string. Now, this is massless. And there might be pulleys, and pulleys change the direction of the string, and they're frictionless. And so people always ask, where do you get this massless string and frictionless pulleys? I'm from the massless string and frictionless pulley store in Penticton, down on Main Street. All right, so we're dealing with strings and pulleys. And so when we have a string, let's just talk about strings. Strings you can only pull. You can't push a string. And so as a result, there is only tension. Sometimes you'll see tension expressed as a T. Generally, I express it as an F sub T. It's a vector, it's a force. And the tension is the same everywhere in the string. So it's a perfect conductor of a force from one point to another. But it only pulls, never pushes. Okay? And you'll see both ends pull. But you'll see that in a second. All right, to start with, we're going to start with a problem. And we've got two blocks that are being held together. And this one is 20 kilograms, and this one is 10 kilograms. And it's being pulled by a force of 60 newtons in this direction. And generally, we're going to be asked a couple of pieces of information. We're going to be asked what the acceleration is and what the force of tension is. And that's the tension in this string here. This tension in here is going to be 60 newtons. All right? Okay, so let's see about taking a look at what forces we've got. For this first case, we have no friction. So these are on rollers or something like that, or sand, or all right, so we're going to have a force of gravity. We're going to have a force normal. We're going to have a force of our pull. And we're going to have a force tension. On this block here, well, we're going to have force of gravity. We're going to have a force normal. And we're going to have a force of tension. All right. So we've got a lot of forces here. But let's consider vertical in the Y. In the Y, the object is not plowing into the table. It's not lifting off of the table. So in the Y, we're going to say that the force of gravity is equal to the normal force, equal and opposite, and that so then the F net is equal to 0. Okay, which basically means we don't have to consider what's happening in the vertical. But then we have to consider in the X direction. And so what we want to do is we want to consider all of the forces that we can enumerate in the X direction. And we're going to set this direction to be positive towards the right. So, and we do this because we know for Newton's second law, F net is equal to ma. the net force that's acting on this system is going to be equal to the total mass times the acceleration of the system. All right, so let's start taking a look. And I'm going to work from the right going backwards. So the rightmost force that we have is a force of pull. Okay, coming back, there's my force of pull. Coming back this way, I have a force of tension. But you notice the force of tension is pointing towards the left. I'm saying the right towards the right, so this is going to be a negative force of tension. And then I keep coming this way, and I have a force of tension. And that force of tension is going to be a positive force of tension because it's going towards the right. And then I have that MA, well, my mass is 20 kilograms plus 10 kilograms times my acceleration. So right away you can see that we have a negative force of tension and a positive force of tension. So these two cancel each other out. They go to zero. This is going to be the case, and it's me. I always want you to list out these positive and negative forces of tension, even though they cancel each other out. I want you to do that because those forces are there. Sometimes you're going to see in some textbooks, some references, they just wouldn't include those forces. They're just sort of glossing over it. I choose to include those and then cancel them out. It's just being complete. All right, so the force for a pull we know was 60 newtons. And then we have 20 plus 10, so that's equal to 30 kilograms times the acceleration. And so the acceleration will be equal to 60 divided by 30. So that's equal to 2.0 meters per second squared. Easy peasy. And so then we come to the second part where we would want to be calculating what the tension is. Now, let's go back and just take a look. How fast is this first block accelerating? Well, it's accelerating at 2 meters per second squared. How fast is this block accelerating at? Well, it's also accelerating at 2 meters per second squared. How can they both be accelerating the same rate? And it's because they're coupled together. They're joined together. And so the string isn't stretching. It transfers a force from this first block to the second block. So if we want to now calculate the tension, when we consider the whole system, the force of tension canceled out. And that's because we were considering the whole system. But if we're going to calculate now what the force of tension is, what we do is that we just isolate one of these objects. So I could choose this object here, or I could choose this object here. Doesn't really matter. So this is part B over here then. All right, so part B, well, what force do we have? Because again, we have net force is equal to MA. Well, our net force, well, we have a force of tension, a positive force of tension. Okay. Is there any other horizontal force? No. Oh, okay. And then we have our mass. Well, what's our mass? So our mass is 20. Hold on. Just over here, you said that is 20 plus 10. But now we are considering just the one block, and that one block has a mass of 20. Well, then the acceleration, so now we're going to use our acceleration. But sir, you always said not to use numbers you calculated. Well, in this case, this question comes from the first. We have to do the first to calculate the acceleration, and then we're going to use the acceleration to calculate what the force of tension is. Okay, sir, I don't like it. I know. All right, so then we can just easily see that our force of tension, 20 times 2, is going to equal 40 newtons. Okay, well, I'm going to do a part C. And the part C is, I'm going to just take a look at what's going on here with the first block, the rightmost block. And maybe let's, I don't know whether to use the acceleration and calculate. Oh, let's do it that way. We're going to use the acceleration. So I'm just going to redraw this block. So we've got this block, and we've got force of gravity. We've got our normal force. We have the force of our pull, which is equal to 60 newtons. And then we have a force of tension, which we just said is equal to 40 newtons. All right, so what we can do, F net is equal to MA. My net force, well, that's going to be 60 plus a negative 40. Right, because this is going the negative direction, is equal to 10 times the acceleration. Well, 60 plus a negative 40, well, that's equal to 20, and that's equal to 10 times A. And then we can easily see that 20, or the acceleration, is equal to 20 over 10 is equal to 2 meters per second squared. I just do this for completeness, and I wouldn't be expecting you to be doing that all the time. But the idea is, it does not matter which block you're using. It does not matter how you're doing the calculation. You're going to come up with the same thing. So this is how we're generally going to analyze the coupled systems. Calculate the acceleration of the system. Once we have the acceleration of the system, then we're going to calculate the tension. Now, it is possible where they might give you the acceleration of the system and then ask for perhaps masses or for tensions and different things like that. So there can be some complexity in these questions, but they're not necessarily, well, not necessarily impossible. They're not impossible. Okay, we're going to do this question again, but now we're going to add friction because it's sort of hard to get rid of friction. So this is still going to be 10, this is still going to be 20, and we're still going to be pulling with 60 newtons. But now we have a coefficient of friction that's equal to 0.10. A little bit of friction, not too much. All right, so let's go on to this. So we have force of gravity. We have a normal force. We're going to have a force of tension. And we're going to have a force of friction now. Likewise, on this block, we're going to have a force of gravity. We're going to have a normal force. We're going to have a force of tension. And we're going to have a force of pull. But hang on, we also are going to have a negative force of friction. Okay, so we're going to skip over the vertical part because we recognize it's not plowing into the table, it's not flying up into the air. The force of gravity and normal forces are all going to be equal. We're pulling with a horizontal force. So let's consider, again, this direction to be positive. Something dinged in my ears, so hopefully things are okay. So we have this is a positive direction, and again, we're going to be dealing with a net force is equal to our MA, and we want to find out what the value is for the acceleration. All right, so again, starting from the right and going towards the left, let's go through and enumerate all of the different forces we've got. So we have our force of our pull plus a negative force of friction, 1, because it's the first block, plus, that's an arrow, a negative force of tension, plus, so that's all of the horizontal forces on this block, there's 3 of them. Then we have our force of tension on the second block, plus our force of friction, which I'm calling 2, on the second block. And that's going to equal, those are all the forces. We got 1, 2, 3, 4, 5 forces that are all summing together. And that's going to equal our mass, and that our mass is still going to be 20 plus 10 kilograms times the acceleration. All right, so we know those two cancel out and equal 0. Reminder that the force of friction is equal to mu Fn, that Fn is equal to the force of gravity, so we could just say this is mu mg in each of these cases. So, so I'll have 0.1 times 20 times 9.8, and this will be 0.1 times 10 times 9.8, and this is our 60 newtons. So this will be a negative value, this, a negative value as well. Forgot the negative sign there, my bad. All right, so we have 0.1 times 20 times 9.8, and so that's equal to, so we have 60 plus a negative 19.6 plus a negative 9.8 is equal to 30 times A. Friction always works against us. Friction is always going to be a negative value. That's where I picked up that I'd forgotten the negative sign here. All right. And so when I add all of these together, I get a value of 30.6 newtons. This is equal to 30 times A, so I divide both sides by 30. And I get an acceleration that's equal to 1.02 meters per second squared. And just a little notice there, you might have read that. Okay, so there we go. We know our acceleration. Notice the acceleration is less than in the first place, in the first example, and that's because we now have friction. Friction slows everything down. But again, we want to calculate the tension. So again, we're going to have to come back up here and choose which one do we want to take a look at. And for laughs and giggles, well, it doesn't. Which one do I want to? Which one do you think? Here, I'll choose this one. This one is the more complicated one. Just more complicated in that we have more forces here. Because we have, 3 horizontal forces, whereas this one we only have 2 horizontal forces. So, generally speaking, choose the one with fewer horizontal forces. Make it easier on yourself. All right, so we're isolating just the first block. And so again, F net is equal to MA. Our net force, well, we have a force of repulsion plus a negative force of friction plus a negative force of tension. And that's equal to our mass, and that's going to be 10 times our acceleration, 1.02 meters per second squared. Force of repulsion is 60 newtons. That remains the same. Our force of friction, well, that was negative 9.8. Because that's the 0.1 kilograms, 0.1 coefficient of friction times the 10 kilograms times the 9.8. Okay, 60 minus our 9.8, and then we have this negative force of tension, and that's going to equal 10 times that, and that gives us a value of 10.2 on this side. Big calculation. So here we have 60 plus a negative 9.8. Did the calculation wrong. So then we have 50.2 is plus a negative force of tension is equal to 10.2. So I'm going to bring this over to the other side and this one to the other side. So I'm going to have 50.2 plus a negative 10.2, and that's equal to force of tension. Vector signs everywhere. And so then we have force of tension being 4 20 newtons. And I'm just going back to check. The force of tension there was 40 newtons. Something's not right. Let me just think. Okay, yeah, that can still make sense. Because our acceleration is now less. It's not accelerating at the same rate. And so the force of tension still then is 40. Okay, yeah, no, we're good, we're good. Sometimes numbers, I don't think the number has to be the same. And this is where sort of the confusion comes in. I wasn't expecting it to be the same. Sometimes they will be the same, and that's okay. All right, so those are coupled systems with and without friction on a horizontal surface. Now we're going to make this a little bit more interesting, and we're going to take and bring in a table, and here comes our pulley, and what we're going to have is one block here, and we have the string, and the string comes over, and we have another block here. And so what's going to happen? Well, we're going to say this one's frictionless to begin with. Frictionless. It's frictionless to begin with, and so we have some forces here, and so we would expect this to move. This is going to come towards the side, and this is going to be pulling it down, and it's going to accelerate. Okay? All right. So let's consider all the forces. Let's consider the forces up here. Well, we've got the force of gravity going down. We're going to have a force of tension force normal going up. I'm getting ahead of myself. And then we're going to have a force of tension going in this direction, frictionless, so there's no other forces happening here. That tension gets pulled along the string, it goes over the pulley, comes down to here. So then on this object, well, we're going to have a force of gravity going down. We no longer have a normal force. Up here we have a normal force because the normal is perpendicular to the surface. Here it's hanging. So there is no normal force, but what we have now in this case is a force of tension. So we're going to be solving this the same way. We're going to solve for the acceleration, and then we're going to solve for the tension. And again, doing the acceleration first. And so now what we're going to do is recognize that if there was going to be motion, this would be the direction. I'm going to choose that direction to be positive. Now, it's not horizontally positive, it's not vertically positive, it's along the string positive. And so when we take a look at working with F net is equal to MA, we're going to take a look at the sum of the forces along the string and add them up. So if we take a look at the sum of the forces, we're going to start here and we're going to go up towards the other side. So we have our force of gravity pulling us down. Then we have a force of tension, but that force of tension is a negative force of tension because it's going up and we're against the string. We're saying the string is, the down is the positive. And then as we come along, the next force we have is this force of tension over here. And so that force of tension is a positive. And that's equal to our total mass. Oh boy, did I forget the masses. So this is going to be 0.2 kilograms, and we'll say this is 1 kilogram up here. So we're going to have 1.0 plus 0.2 times our acceleration. All right. Well, here again. Negative force of tension, positive force of tension, those things have to be the same. So these go to 0. We don't have to worry about that. Here we have our force of gravity on our 0.2. So it'll be 0.2 kilograms times 9.8. There's the accelerating force, the force that's pulling it down. Over on this side, we'll have 1 plus 0.2. So that's equal to 1.2 kilograms times our acceleration. And so now we'll have 0.2 times 9.8 over 1.2, and that's equal to A, and that's equal to 0.2 times 9.8 equals 1.96 divided by 1.2. That's equal to 1.63333 repeating meters per second squared. There is the acceleration. All right, so now we need to calculate what the tension is. So this object here is accelerating at 1.6 meters per second squared down. This object up here is accelerating at 1.6 meters per second towards the right. Which one do you want to choose to do? Doesn't really matter. This has two forces that are along the acceleration line. This has only one. Let's do this one. Now, I forgot to state, but this is a horizontal surface, so we have force of gravity, we have the normal force. Those are going to be equal and opposite. It's not being pulled into the tabletop, so gravity is not pulling it down. The table's supporting it. Normal, it's not flying up into the air. So these two forces, the acceleration up and down is equal to 0. So these two forces have to be equal and opposite, adding up to a net force of 0. All right, so then we will consider that we have a force of tension in the positive direction. That's the only thing. And we have a mass times our acceleration. Well, a force of tension, that's what we're trying to find. Our mass, we said, was 1.0 kilograms. And our acceleration is 1.6 meters per second squared. And this calculation I can do in my head. My force of tension equals 1.6 newtons. That's going to be the amount of force that is accelerating this whole system. But that's the tension that's accelerating this. That's the tension that's holding this back. All right. So this is a coupled system. Lay it out. Draw out all of the forces that are involved. Calculate the acceleration of the system. Calculate the tension. It's getting close. Well, it's lunchtime. I'm getting hungry. So this one's going to be really, really quick. All right, we're going to do this one again. So here's our tabletop, table leg, frictionless pulley. But now we're going to, there's a string, 0.2 kilograms, 1.0 kilograms. But now we're going to have force of gravity. We're going to have normal force. We're going to have a force of tension. But now we have a force of friction. Likewise here, we're going to have a force of gravity going down. And we're going to have a force of tension going up. But no frictional force because it's not in contact with the surface. All right, so we're going to do it the same way. We're going to define this direction to be positive. So we're going to have a force of gravity plus a negative force of tension, 1, 2, plus a positive force of tension, plus a negative force of friction. And that's equal to our total mass, which is 1.0 plus 0.2, and then times our acceleration. All right, so these cancel out to be equal to 0. We'll have the force of gravity, which is 0.2 times 9.8. Then we have this negative force of friction. Well, that negative force of friction comes from the coefficient of friction. Oh, coefficient of friction, 0.1, like we had in the last friction example. And so then our force of friction we can recognize as being mu mg, where mg is equal to the Fn. You remember. So this is 0.10. Our mass is 1.0 kilograms, and our gravity is 9.8, and that's equal to 1.02 A. So we have 0.2 times 9.8, which is 1.96. And so here we have 0.1 times 9.8, so it's going to be 0.98. That's equal to 1.02 times A. So we have 1.96 minus, so that's going to be 0.98 newtons on this side. So you want 1.02 A divided by 1.02. My fingers aren't hitting the buttons right. 0.98 divided by 1.02, and that's, so A is equal to 0.96 meters per second squared. Okay, so now we need to calculate the tension. This time I'm going to choose this one here. And so we're going to have our force of gravity plus a negative force of tension, and that's equal to our mass times our acceleration. Force of gravity, well, that's 0.2 times our 9.8 plus negative force of tension that we're trying to find. And we have 0.2 times 0.96 meters per second squared. So this would be 1.96 newtons plus negative force of tension. Then we'll have 0.192. And so we're going to bring this over this side, bring that over the other side. So we're going to have 1.96 plus a negative 0.192. And that's equal to our force of tension. Sorry, just checking things on my calculator again. So we're going to have this plus a 1, we subtract them, and so our force of tension comes out to be 1.77 newtons. And there we have our force of tension. All right. So coupled systems. Label all forces. Positive, note the positive direction. Generally solve for A. And then solve for the tension. That's pretty much the steps. All right. There you go. There will be a worksheet that's attached to this, and then we'll have some other questions. I'll be giving a bit of time for some of these things, so we'll see exactly how this week finishes off. All right, take care.